Okay, so this video is a continuation of the Chapter 9 notes on ellipses, so this is part 2. And so far we've thought about ellipses as you take the unit circle, so radius 1, centered at 0, 0, and then you stretch it out horizontally, you stretch it out vertically, and then you move the center point around. But that's just one way of thinking about ellipses. There is another way, and that's not based on vertices or co-vertices. It's based on two things called focus points. So you pick a point and a second point, and then you figure out all the points where this length right here, which I'll call R1, and this length right here, which I call R2, is a constant. R1 plus R2 equals a constant. And another way of thinking about that is, imagine you take a piece of string and you pin down the two ends at the focus points, and you take a pen and you put it right there, and then you move the pen around. So this string gets moved around. So like when the pen is here, the string would look like this. And you keep the pen so that the string is tight. And then you move the pen around and you'll actually trace out this ellipse. And to kind of show you how it works, I found this image online. And there you go. You can kind of see that would be the pen moving around. And the string is a fixed length with the ends stuck on those things called focus points, or foci is the plural. Okay? So that's another way of thinking about an ellipse. So the question is going to be, well, how are the focus points? If you know the focus points and you know like how long the string is, can you figure out the equation of the ellipse? Or depending on what information with the focus you're given, can you figure out what the ellipse's equation is? Now there's a tip that I give here. When you're dealing with focus problems, a good thing to do is to place the pen on the vertex and analyze stuff, and place it on a co-vertex and analyze stuff. So we'll actually do that right now. So the distance from a vertex to a center point is usually labeled with A. Remember, here the distance between the two vertices, that's the major axis. Major axis is 2 times A, right? Well, if I put my pen right here, then the string would go like that, right? And if you think about it, so that's from focus 1 all the way to, I'll call that point P. So focus 1 to P plus P to focus 2 is really going to be the length of the string. But if you look at this part right here, from P to focus 2 right there, that's actually the same length as this part over here. So if I call this like, actually, let me call this, I don't know, what letter do I want? Q, right? Well, P to F2 is the same as Q to F1. So if I did F1 to P plus Q to F1, and then think about what that is. That's this plus this, right? Well, that's the same thing as the major axis. So it's still the length of the string, but that's the same thing as the major axis, which is 2 times A, right? So the string is exactly the same. It turns out that the string is the same length as this major axis right here, right? No matter where I connect the string to, this plus this is the same as all of that red line straight through the middle. Okay? All right. So let's keep that in mind. Major axis is 2A. Sorry, that got erased. And then this is key here. Length of string is 2A. So the distance from a co-vertex to a center point, so from here, let's say that's the center, to a co-vertex, which would be here, is usually labeled B, which we've been talking about. And the distance to a focus to a center point is usually labeled C. And then we're supposed to figure out a relationship between A, B, and C. And the one thing we know now, the major axis equals 2A, which is also the length of the string. And the hint here is put your pen on a co-vertex. So we'll put the pen right here. So the string would look like this. There's the string, right? Now, the string actually, because I put it on a co-vertex, these two triangles that I formed are exactly identical to each other. So this is a C here too. And we know that the length of the string is 2a, but since I placed it right here conveniently, this length and this length are the same, so each one is a. Now, if you did Pythag on this, you've got that b squared plus c squared equals a squared. Now, I realize that's a little confusing because the way you learn Pythag, it's a squared plus b squared equals c squared, but we've put the a, b, and c in different places. So this is the relationship that you want to know, right? A equals distance from center to vertex. B equals distance from center to co-vertex. And C equals the distance from the center to a focus point. All right. So this is a huge relationship that will shorten some calculations that you need, especially when you're dealing with focus points. Okay, so here's a summary of what we've talked about up to this point. Major axis is 2a, distance between focus points is c plus c, that's 2c. R1 plus R2 in this case is a constant, which happens to be the same length as the major axis 2a. And then the minor axis is b plus b, so 2b. All right. So let's graph this ellipse equation here. Oh, those 2's got cut off somehow. Okay, and then we're supposed to label all this stuff. Well, notice the 9 and the 16 aren't inside the parentheses, so if we put them inside the parentheses, we get x minus 1 over 3 all squared plus y plus 3 over 4 all squared equals 1. Okay, so we've got the center. That's going to be at 1, negative 3. We've got the horizontal stretch equals 3, and the vertical stretch equals 4. So let's go ahead and plot those. So 1, 3, 1, or negative 3 right there. So 1, negative 3. Then I've got to go 3 units to the left and right. So 1, 2, 3. That's going to be 4, negative 3. And 3 units to the left will be negative 2, negative 3. And notice the stretching horizontally is smaller than the stretching vertically. So these lengths right here are going to be my co-vertices. And this length is going to be a B, not an A, because it's smaller. So B equals 3. Okay, and this is a co-vertex too. I'll just do COV. So then if I go up 4 for the vertical stretch and down 4, 1, 2, 3, 4, I'm going to end up at 1, negative 7 for vertex, and at 1, 1 for my other vertex. So here's the ellipse, something like this. There's my ellipse. And the one other thing I needed, a foci. I got to figure that out. Well, this stretch was bigger, so this is my A. That's 4. And then I now know that a squared plus b squared equals c squared. So let's use that. A squared equals b squared plus c squared. Okay, so that's 4 squared equals b squared, which is 3 squared, plus c squared. So that's 16, and then if I bring the 9 over, that's c squared, which is 7. So c equals root 7, or plus or minus root 7, but it's a length, so I'm only counting the plus. Well, the foci need to fall on the major axis here. So, maybe roughly here and here, let's say. So the foci, well, I know that c is root 7. So this distance is root 7 up and root 7 down. So then I know my foci, the x coordinates are going to be 1, and the y coordinate, the top one will be negative 3 plus root 7, or I got to move down root 7 from negative 3. So there are the coordinates of my two foci. Okay. And then we've got the center point, and we've got the vertices right here, and we've got the co-vertices right here. So that's everything that the question asks for. Okay, let's look at 9. Write the equation of this ellipse. Okay, vertices at -4, 1, and 6, 1. Co-vertices at, foci at -2, 1, and 4, 1. So let's figure out where the center point is. So right in the middle of -2 and 4, if I average those, I get 2 over 2, which is 1. So the x-coordinate here is 1, and then the y-coordinate is 1 for everything there. And so we can figure out some values here. I know that from here to a focus, that's C. And so in this case, C is 3. And I know from here to a vertex, that's A. So this is going to be 5. So then if I needed to figure out B, I can do that using my handy equation that we figured out. A squared equals B squared plus C squared. A is 5. B we don't know. And C is 3. So then I've got 25 equals B squared plus 9. So 16 equals B squared. So B is going to be 4. Since it's a length, I'm ignoring the -4. So B is 4. And so now I know that my stretch out this way is 5, and my stretch up and down is 4, and the center is at 1, 1. So I can write the equation. Since the center is at 1, 1, I've got this set up first, and then I stretched it 5 units out in left and right, and 4 units up and down. So there's our equation. Okay, and then we've got one problem left, and it's similar to a problem that we did with circles, where this is like the foiled out, simplified version. But the idea is that we want to write it so that we can actually figure out what this thing looks like. So we want to write it in that standard form that we had before. So just like the circle one, we're going to complete the square or turn into vertex form this term, the x terms. Then we'll do the same thing with the y terms, and then we'll switch them out for the new versions. So in this one, my a is 9. The h coordinate of the vertex is going to be -b over 2a, which is going to be positive 18 over 2 times 9, which is 1. The k we get just by plugging it back in, so 9 times 1 squared minus 18 times 1 is -9. And so in vertex form, this thing turns into 9a x minus h squared plus k. So it turns into that. Okay, so this is something we'll replace this term with up above. Okay, so let's look at the green one, the y's. So a is 4 there. H is going to be -b over 2a. So -16 over 2 times 4, which is 8, so -2. K, when we plug it in, will be 4 times -2 squared plus 16 times -2. So that's going to be 4 times positive 4 is 16, minus 32 is -16. So then we get a y minus h, so plus 2 squared, plus k, which is -16. So then if I rewrite this whole equation, I'll write the new red box, which is 9x minus 1 squared minus 9. And then the new green box, which is 4y plus 2 squared minus 16. And then I've got this extra minus 11 equals 0. And then let's keep the parenthesis terms on the left side and get everything else to the other side. So if I get everything on the other side, it becomes positive 9, positive 16, positive 11. And if you add those all together, it comes out to 36. And then we want this to be 1 on this side. So we're going to divide everything by 36. So we get x minus 1 over 4 squared there. And then y plus 2 squared over 9 equals 1. And then we can kind of gobble them up into the parentheses. So x minus 1 over 2 all squared plus y plus 2 over 3 all squared equals 1. And then from here we can graph it pretty easily. The center is going to be at 1, -2. The horizontal stretch is going to be 2. The vertical stretch is going to be 3. So let's go ahead and graph that. So I'm just going to say, here's the center, right? 1, -2. If I go 2 units this way, then I'm going to be at 3, -2. If I go 2 units this way, I'm going to be at -1, -2. If I go 3 units up, the y's increase by 3, so that'll be 1, 1. If I go 3 units down, I'm going to be at 1, -5. Here's my ellipse. And then the only other thing I need is the focus, the focal points, the foci. Well, this is 3, this is 2. So the bigger one is my A, and the smaller one is my B. And then I know that A squared equals B squared plus C squared. So 3 squared equals B squared plus 2 squared. Oh, whoops, sorry, 2 squared plus C squared. So that's 9 minus 4 will be C squared, which is 5. So C will be √5. So then I can figure out that my foci are going to be at, and then I take my center point, and the foci have to go up and down in this case. They can't go left and right because I need to move along the major axis. So the foci will be at 1, -2, where I go up √5, and 1, -2, where I go down √5. So there are my focal points. All right, I hope that helps a little bit, and I'll see you guys in class.